Okay.
But it's just this.
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 Hey everyone, welcome to the community meetup. I'm going to share a link in the chat. You can take a look, and there's material related to the whole meeting. You will find the code about the antennas application. You will find blogs about Materialize, different applications from community members, and for other developer experience engineers here in Materialize. So, well, let's begin with the talk. Oops. Let's see, here we go. So I'm Joaquin Colacci. I'm a developer experience engineer here in Materialize. This community meetup is going to be about how to build real-time applications, different patterns and things that we can do with Materialize. Before joining Materialize, I was also building data pipelines, building applications, real-time applications, data warehouse, trying to build real-time data pipelines to fill data warehouse and applications at the same time. And the last year, I was also building a visualization tool. If you have been in the last year community meetup, we saw streaming, a tool to build real-time visualizations. So I have also faced different issues trying to build real-time applications in the front end, in the back end, in the whole full stack, and in the pipeline. So, well, I hope this meetup to be useful for you, to learn new things, and to be fun. So let's begin. The first question, I'm going to ask 3 questions in the first 20 minutes, and this is the first one. So you can write your answer in the chat so I can see what the answers are. What is the oldest real-time dashboard that you know? It can be something like in a train station. It can be something in real life. It can be something like in a web application. It can be something like in Nintendo GameCube in a game. It can be anywhere. You can think one and write your answer on the chat. I see that there's a new message now in the chat. Send your answer over there so I can also know if you are alive. Okay, so we have some answer here. We can see an auto. Okay, good answer over there. So he said a very good dashboard. Let's see the one that I was thinking about. It's the one in a car, the dashboard that we have in a car. And we see every day, if you have a car and if you drive a car, you're going to see this dashboard every day. This happens in real life. This is a real-time dashboard that has been built years and years ago. And it's a wonderful example about the real-time dashboard or a real-time application. It works very smoothly. The experience that we have with this dashboard is very nice. The needles, they move very smoothly when the car speed goes up. And if it goes down, the needles are going to go down very, very smoothly. The same happens with the gas, with the oil, with the water, or with any other signal that we press on the car. Any button is going to be shown in the dashboard immediately. So this is a great example of a real-time dashboard and a real-time application. We need to try to have the same experience if we want to be fully real-time, the same experience in our application. It needs to feel natural, okay? So the next question is going to be, what is real-time? This is like big data was 10 years ago. 10 years ago, big data was, everyone was doing big data, but in reality, nobody was doing big data. It was a mess. It was a busy world, and there wasn't too much information around. Different people had different definitions. There were memes all the time about big data, and it happens something similar with real-time right now. Everybody talks about real-time. Everyone is doing real-time stuff, but what is real-time? It is the processing in real-time. It is serving information fast. Is that real-time? So there are multiple definitions. Every company will have a different definition. Every developer will have another definition. So it's a mess right now, but we can define a few things in common in different products, in different companies, and in different technologies. And these are the 3 layers that we can see over here. We have the processing layer. This is also known in the Lambda architecture. We have the processing layer, the serving layer, and the reading layer, okay? We have a source where the event gets created and then it gets processed. This can be done by a real-time tool, a real-time technology, a real-time framework, a microservice. We can have anything here that processes this information. It can be in a streaming way or in a batch way. Then we tend to serve that information. We are going to use, normally we have here a database. We have also another microservice, but usually it's a database here that is serving the information to the customers, to the clients, to other microservices, to other services, or to a pipeline. And people tend to come here also real time to different things. For example, if you have a Materialize view that updates very fast every 10 seconds, people is going to tell, okay, we have real-time stuff in our database. Or if you have a database that can query very, very fast, they will call that also real-time. So if you can query and get the answer in less than a second, in huge amounts of data, they are going to call that real-time. And then we have the reading layer. The reading layer is how we get information out from these databases, from the serving layer. This can be in different ways, but the most common are the query. Okay, we run a query in the database, we retrieve the results, and that's it. Or we subscribe to the database and wait for the updates. So if there is any update in the serving layer, we are going to receive that update in the reading layer. This could be an API, for example, reading from a database and then sending the results to a client. And this client can be our product, our application, another data pipeline, or a microservice. Okay, so the event borns here and dies here. This is the end-to-end life of an event. And this gets more and more challenging if we try to do all of these layers in real time. For example, if we try to subscribe in real time to a database and we want the database to send us results in real time, that's going to be challenging. It's going to be a little bit complex. So we need a very good database that can serve very, very fast. But that it's only the first issue. If we try to also process in real time, if we need to process information in real time and serve that in real time, it's going to get more and more challenging. We need to scale, we need to do everything in an efficient way, and we need to connect all of these layers in a real-time way. And that gets very, very complex, and even more when you try to scale and you try to do everything in an efficient way. So the next question is, how much is real time? So we have the processing layer that is processing very, very fast. We don't know how fast. If we are using batch, maybe for some people, that's going to be fast, running a batch in 1 minute. For many companies, that's going to be real-time information. If you are doing micro batch, that's going to be near real time. For some people, that's crazy, but it's like that. And then you have a streaming. People used to call it streaming also real time because as soon as one event arrives, we get the result. So people tend to call that real time. So there are different measures to the real time world. The same happens in the serving layer. We can get results in less than a second, and people are going to call that real time. If the Materialize view updates every 10 seconds or every 1 minute, they can call that also real time. And the same happens with the reading layer. If we read the results from the database every 1 minute, this is very common in visualization tool. They get the results from the database every 1 minute or every 30 seconds. They call that also real time. So there are different values for the real time world. And in the end, it is a matter of perspective. It is a matter on who is looking at the information. It depends on the market. It depends on the business. It depends on the customer. The most important part is it depends on the end user. if the end user is used to read information every 1 minute, and we have a new solution that can present the information in less than a minute, for example, in 10 seconds or in 5 seconds, is going to call this new solution is going to be the real-time thing. And the old one is going to be the no real-time thing. So it's always a matter of perspective. If we can process faster than before, we are going to call the new thing the real-time stuff. And the old one is not going to be anymore the real-time stuff. This happens in every business, in every market, and in different segments of customers. You will find that, for example, in finance, real time is going to be almost a second, and there is no other type of real time. So Materialize powers these real time applications, these real time pipelines that needs to get the result in less than a second. We want to get the best out of real time. We want to be the most real time thing out there. So how Materialize does this, how Materialize can power this type of applications or data pipelines. So internally, Materialize do incremental results. You can find more information in Notion. There are 2 blogs, very good, about view maintenance and Materialize views. And these are the ways that Materialize does internally to, rather than calculate all the information again and again, is going to do incremental stuff. So the incremental stuff, what it does is, rather than consuming the same information again and again, is going to maintain the result in memory. And if there is any update, it's going to update that the results. As soon as a new event arrives, it's going to update the output. The data is all in memory. You can create index. You can create index to make the queries go faster, to make the processing stuff go faster. And you can also run a query and tail. I'm going to talk about tail later in the next slide, but the query is the normal query that you can do in any database, in any SQL database. And the tail is a way to subscribe to results in a Materialize view, in a view on a table, or in any type of source. So if we go back to these 3 layers, we have the processing layer, we have the serving layer, and the reading layer. Materialize can work on any of these layers. Materialize can process in real time, doing incremental stuff, rather than processing all the things. And when we request, it's going to be calculating inside the results that we want. So here, Materialize can process the things in an incremental way, in a streaming way. We can also run a batch process, but it will make so much sense. And it's going to serve the information also in real time. This is a very good thing, because rather than having to refresh the Materialize views to get the last results, Materialize can do that for us automatically and in an efficient way, doing incremental calculations. And the same happens in the reading layer. If we want to retrieve the results from Materialize, you can run a query, or you can run a tail and subscribe to those incremental updates. So you have the end-to-end in a real-time way and in an incremental way. So you can build a real-time application or pipeline in a more efficient way. So all these challenging problems, you can solve them using Materialize in the middle, processing, serving your information, or reading or serving as a reading layer for your clients. Here you can use multiple applications and multiple web services or React apps or anything that you want. So why not others? There are multiple technologies out there in the market that they say they do real-time stuff. As you know, real-time is everywhere right now. So why not other products? So with Materialize and incremental computations, you can reduce the latency over your queries and over your subscriptions. The same happens if you try to do this by yourself. If you try to build an efficient processing framework or a microservice that is processing all the stuff, it's going to get very challenging, and you will not have features like multi-way joins or the strong consistency that you can have with Materialize. One thing that I love is that with Materialize, trying streaming stuff gets a lot more simpler. Materialize is very lightweight. So if you run an instance in your machine, in a cluster, if you try to deploy, it's going to consume just a little bit of resources comparing to other technologies that you need to deploy a whole cluster to try something. So you come with Materialize, you can deploy on your machine, run SQL, create a source, start processing stuff. It gets very simple, and you will feel that it is very flexible. You can drop any Materialize view, you can process any process that is processing information, you can drop that, create a new one, replace another one. It's very flexible. So I'm going to do a very brief pause so I can drink a little bit of water. I don't know if anybody has any question. I'm going to read the chat. And at the same time, if someone wants to go to drink something or it's something, it's okay. I'm going to share a link. I'm going to share a game that you can play. It's a real-time game. It's called, I'm going to check the questions. Okay, I'm checking the questions right now. Yes, so there is a good question about, Postgres can have big amounts of data in disk and Materialize. Maybe you are using the memory to store that information. And I'm going to show something later to avoid that. So you can handle different amounts of information. And also there is a future thing that I can talk, that is the platform that will help to scale many use cases like this one that there was someone asking. I'm going to share a link, is realtimestuff.com. You can go in there. There is a game where you can do clicks in a circle, and those clicks that you are doing are going to get aggregated by Materialize. It's going to process all the information, and it's going to serve the results in real time. If you are fast enough, you are going to be in the leaderboard. The fun thing about it is that we are using two approaches. We are using the query to retrieve results, to retrieve the leaderboard, the people that is fast enough to be there. And we are using tails to get who is connected right now in the application. I'm going to share the code later if someone is interested to learn how to build stuff like that for other applications. And we are going to see the antennas demo in the next 20 minutes. So I'm going to take a pause. It's going to be a few seconds. I'm going to drink some water. So you can go to the game, to the link, play the game, do some clicks, and check if you are in the leaderboard. I'm going to check. Okay, I want to see the screen. I want to see the game. I want to see the people playing. Just for a minute, I'm going to stop the tab. Okay, there is so many people playing right now. And we can see the dashboard, the leaderboard that is changing in real time. So here we have the 3 fastest people. Which advantage? Oh, now there is an expert here who is 100. I think he's a hacker. Probably he's a hacker. So I'm going to show something here in my screen. I will show you the difference between a tail and running a query. As you can see, the query, when we are running a query in a real-time applications, we are receiving updates all the time. We are requesting information to Materialize, and Materialize is returning us in real time. If we are doing a tail, we will only get this type of results. For example, the users that are disconnected or connecting in real time. So if there was no user connecting to Materialize, there will be no update. And if there is someone logging in or logging out, we are going to see that. We we can react to those events, okay? So, well, let's continue with the slides. Let's continue with the meetup. I hope that you have enjoyed the real-time staff game. So let's talk about the telecommunications example. You can find the code in Notion again. You have one repository for Kafka or Redpanda, and another repository to build this application using Postgres. There are two ways to do it. You can use other sources like S3, but we're going to talk about it in a minute. So what's the issue with the telecommunications companies? As you know, they have antennas around all the city, so they can provide internet access to the customers. And there's a big issue if a user, if a customer has a bad internet connection. For example, you are in a phone call and then the internet connection goes down, you are going to blame to your service provider. And if you see another company, probably you will swap. People in the business call this churn. So churn is a very serious thing, even more in telecommunications companies. They lost a lot of money every month and every year, millions of money, because people move from one company to another. So they try to predict who are going to move to the company, and they try to keep those customers. So to make it easier to avoid this churn, telecommunications company try to find issues in the antennas as fast as they can, okay? And they also have to maintain a level of service, otherwise there are penalties. And the operations team needs to see this in real time. So if you're working at a telecommunications company, there is an antenna that is working bad, and you want to replace that antenna very fast or help that antenna to get a better performance on the area. So how does even a 4G or 5G antenna looks? If we are walking on the street, it looks like this. It is this tower, this white box. This is a 4G antenna. If you're walking on the street and you look to a tower, you will find a lot of these ones. So if you see that something is working bad, maybe this antenna is not working fine. So what's the problem? What's the problem here? If we try to do this with batch, it's going to take a lot. 10 seconds is a lot of time for a customer who is having a bad connection. They are going to experience the bad connection very fast. If you're in a call, you're going to experience that immediately. And the operations team is going to have big delays to see that in a screen, to see that information in their visualization tool, for example. So we want something more real time. Rather than 10 seconds or 1 minute, we want to see updates every second. We want to detect the issue instantly. And we want to understand what's happened every second. We want to see what's going on. So the result is that we are going to have Materialize, processing and serving the information. And we are going to have another microservice reading from Materialize and a web application reading also from Materialize. There is going to be an API helping the microservice and the web application to get the information out from Materialize. So the first step when we are working with Materialize is to define a source. It can be Postgres, it can be Kafka, it can be S3, it can be Redpanda. The big difference between these sources is that they can have a defined schema. For example, in Postgres, if you are used to build web applications, probably you know more about Postgres than about Kafka or Redpanda. If you are used to build data pipelines, probably you know more about Kafka or Redpanda than Postgres, and it's okay. The big difference is that in Postgres you have a schema defined. In S3 there is no schema, and in Kafka and Redpanda probably you have a schema. If you want to scale correctly, you have a schema. If you have no schema because you are testing things, that's okay. You have both options. The big difference is that you will have to parse the information when there is no schema, and when there is a schema, Materialize can do that for you. So how will this look without Materialize? We will have a Postgres instance. We'll have an events, for example, from the antenna provider. There is going to send us events about the performance of each antenna that we have in a city or in an area. It's going to send us key performance indicators about how the antenna is doing. And then we have information about where the antenna is, the name, the street, the position in a map, and different stuff that is going to be useful. So this table is going to be static. There will be no changes. Maybe if we add a new antenna or nothing. And then we have the events table. In the events table, we are going to get results all the time. We are going to get updates all the time. So if you are not using Materialize, probably you will want to create a service, reading from Postgres or maintaining information in Postgres. Postgres is going to recalculate all the stuff all the time. It's going to reprocess the same information again and again. And to avoid that, you want to use a cache with your service, maintain the same cache. You will maintain your information in your cache. And in Postgres, you have the same information in two places. Then you have your application reading from the cache, reading also from the service or only from the service. So it turns into a mess. You have different layers. You have the serving layer here. That's going to be okay. Then you have the processing layer and another serving layer here. So it gets confusing where to get information. If you try to build new services, it's going to be complex because this service needs to scale. So it's going to get very, very complex. So the result is that we can replace a service, a cache, and whatever we have behind this, if it is a data processing framework, if it is a framework that we build by ourselves, because we are developers and we like to build things, we can replace everything with Materialize. So Materialize can read directly from Postgres, maintain the information in sync. If the instance goes down, there is no problem. You can recover the information from Postgres, and then you can plug in your applications to Materialize, or if you have another service, you can read also from Materialize. So how will it look if we are using Kafka or Panda? It's very similar. Rather than having two tables, we have two topics, one for the events and another one for the antennas information. And we are going to have a service reading from Kafka, sending that to another database, maybe a NoSQL database or anything. And we're going to have our applications and other services reading from this database or from the service. So again, we have another database to serve the information. We have service processing the stuff or a data processing framework. We are sharing information here, in the same place here. We need to maintain the sync over here. It gets more and more complex. So the idea is that we can replace all of that. We can replace the serving layer, we can process the processing layer, everything with Materialize, and you can connect multiple services and applications all to Materialize. You can use queries, you can use tails, you can do anything. So after we have defined the source, it doesn't matter if it is Kafka, Postgres or S3, we need to define how we are going to process and serve that information. So if we have defined a source like Postgres, we are going to have a schema. Or if we have defined a source like Kafka with Panda with a schema and registry, it's going to be okay. We have a schema defined. So there was a question in the chat about what happens when I have terabytes of information in Postgres. And I have memory in Materialize. How I keep all this information in Materialize? That's going to be an issue because I'm reading information from Postgres is going to blow up my memory. What can I do? So one way to solve this type of issues is to use temporal filters. There is a link in the Notion page about temporal filters. It is a way to remove events that I'm not going to use. For example, for our case, we are using only the last half-minute events, and we are using that to keep only those events in memory. So the events that you are not going to use, you can keep them out from Materialized memory. If you need to get them from Postgres, you can create a new Materialized view, reading from the source and getting that information from Postgres. I don't know if the question has been answered for whoever was asking that question. I'm going to check at the end, but I hope that this is the correct answer to your question. And the other way is that if we have a schemaless source, this is a source that has no schema like S3 or Kafka and Repanda without the schema registry, the first thing that we are going to do is to parse the information in a materialized view and apply a temporal filter. So with the temporal filter, we only keep a small subset of the information, and we can iterate over this materialized view. Okay, we parse the information, we remove the events that we do not want or the events that we want to test with, and then we create the different materialized view on top of the same materialized view. So rather than consuming the whole events, the whole information from Postgres or from Kafka, we can only use the last minute information, okay? Or the last 10,000 events, for example. This is going to make a lot easier to iterate and to try new things, to try how a materialized view is going to work. If we have a new SQL query, we can run the query on top of this materialized view and it's going to be faster, okay? So how does it look internally if we try to apply this to our approach in the antennas solution? So we have Materialize reading from Postgres, and we are going to have two materialized views. Here we have the antennas, and here we are materializing all the events. So there is an issue here that I will let you guess that Materialize will face in the future if we do not apply a temporal filter. After this, we are going to do a join between two tables, and we are going to apply a filter, a temporal filter. We are only going to read the last half minute information. We are going to aggregate all these events and serve to our backend and to our front end and to our microservice. If we're using Kafka, it's similar, but rather than have only one source, we're going to have two sources, one per topic. So we have the events topic, and then we have the event source. If we have the antennas topic, we are going to have the antenna source. This is more clear to work with. I recommend to go with this approach. And the next one, since we decided to create a source without the schema, the first thing that we are going to do is to parse the information. Since we only want the last half minute information to use to get less information into memory, we are going to filter by the last half minute. Then we are going to join that and do the aggregations that we need. You can find all the code about this parsing stuff, the joins, the aggregations, the temporal filters. You can find everything in the repository, in the GitHub repository. So the big difference is that Kafka and Repanda is using temporal views. Okay, so we are filtering information. In the case of Postgres, it's doing C2C, so everything goes into memory. If we have tons of memory, it's going to be all right. But if we have a limited amount of memory, it's going to blow up in some moment. So these are a big difference. And as I was saying, it's going to reduce that in memory. We can speed up new materialized views. We can speed up testing. We can speed up a lot of things when we are trying to build something. The best scenario when we are creating materialized views, when we are processing stuff, is okay, when should I stop creating materialized views? When I'm done processing stuff. So the best case is when from the client side, you are only doing lookups. So lookups is just get me this value, or filtering and getting some value. Okay, you have your index created, you have everything created, your materialized view is running, you have an index in this materialized view, and from your client, you are only selecting things from your materialized view. Okay, if you have to do an aggregation from your client, probably you can speed up that with a materialized view. If you have nothing else to do, then you are done. That's the best case. You are going to do a lookup, and that lookup is going to be very, very fast. After we have defined how to process the information, okay, we have created the aggregations. We are aggregating by antenna. We can see the results in real time. We need to define how to read the information out from Materialize. It can be a query or it can be a tail. We have these two ways. These are a difficult question to answer, and because in many cases you can use any approach. Okay, if your use case needs real-time information, as we have seen for the real-time staff game, we can use both approach. We can use a query getting the results all the time from Materialize, or we can use the tail getting the results when there is an update. So you have the two approaches and we can use both. But always one is going to be better than the other one. This is a trade-off and it depends on the use case. One will be more expensive than the other one. For example, in the real-time staff game, if we are running a query every second and there is no user connected to the product, then it's going to be wasting a lot of information, processing power in Materialize, and different stuff. If you are running a tail, since there is no customer connected, it's going to do nothing. So you have a trade-off that you had to measure, you had to test. You will say that one is going to be more natural and it will fit better than the other one. But this rule does not apply to some changes, to some cases, like when you need to replicate changes. So with the tail, you can receive all the updates and send those updates to other places. With the query, you need to run the query all the time, again and again and again, and you will lose a few changes in the way. So I made this little table over here to know when to use a query or when to use a tail. So if you have to listen to every change, I recommend to use the tail. If you have a table, if you have a Materialize view that it doesn't change very much, for example, the antennas position or where they are not going to change frequently. So we can use a query over there. If we need to react to events, then the tail is going to be better. That's like the real staff game. We need to react to the users connected. So the tail is a good example over there. If we need to get the value only once, for example, you are searching some information in your database, you want to do that in real time, and you get the result only once, and that's it. There is no need to create a tail to get new information because you had only one question. And then you have the most difficult case where you had to decide, okay, is this a query? Is this a tail? Again, you will feel that one is going to be better and the other not. Probably both are going to work good with the use case, but it will depend on the architecture. If you have a streaming data pipeline, or if you have a batch in your bag, it all depends. It depends also in the application that you are trying to build. And if you are using sockets, if you are using HTTP, it depends on many factors. So you have to do a trade-off between the query and the tail. For our case, we're going to use a tail because we want to react fast. Okay, we have the antennas. The antenna's performance is going up and down. And if the antenna performance goes down, we need to fix that very fast. So we want to run a tail. And if there is a low performance happening in one antenna, we want to replace that immediately. We want to create a service that can react to that. Okay, so that's why we defined the tail. If we wanted to do this with the query, probably we will have a query running every second or in less than a second, getting the same information again and again from Materialize and reading that. It's for this case, for example, that is going to be also okay. But since we want to be more reactive, we have decided to use the tail. So how it looks. Currently, it looks like this. We have Materialize, we are running a tail and sending that information to the applications and to the services. Okay, here is going to be an API. We're going to talk about the APIs in a second. And in the Kafka and Red Panda case, it's going to be the same. We have Materialize, we are reading from Materialize using a tail. So as you can see, if there is a new event, it goes to the events topic, it goes through Kafka or Red Panda, goes directly to Materialize. Materialize is going to calculate incrementally that update, and it's going to send the update to applications and to the services. So we can see how fast we can react. There is no need to ask all the information to Kafka to reprocess or to see where is the event and all the other events, or there is no need to recalculate inside Materialize all the events to get an answer. We can just do one update inside here, and we are going to send that update also to our customers. So we have defined how to read information. We are going to use tail. We have defined how to process and serve. We are going to parse the information. We are going to do the aggregations. We are going to serve that with the tails. And we have defined the different sources, Kafka and Postgres. We could have decided also to use S3, but only these two for this time. So we need to define which technologies are we going to use to read the information from. So we have different options here. We can use, for example, GraphQL with sockets, or GraphQL with server-sent pins, or with HTTP. It will make so much sense with HTTP too. We have REST. With REST, we can do almost anything. With gRPC, it's very common to do HTTP too. We can see that there is many companies doing gRPC streaming with HTTP too. There is information about how to run GraphQL with sockets in an efficient way, rather than using Apollo to run GraphQL. There is other frameworks that can help you to build sockets in GraphQL. We have decided to use that. Since we are using tails with sockets and server-side events go very, very nice. I love to use sockets with GraphQL or REST, and then plug in a tail on top. So this is the case for the antennas project. And for the game, for example, we have used the REST API with socket. It's also very simple. I'm going to share that code later. So it looks like this. We have Materialize reading the information from our source. Okay, we have a tail sending the information to GraphQL. GraphQL is our API, and we have a microservice reading from GraphQL and a React application reading also from GraphQL. So one thing that is very common to do when you are using tails, for example, if since the application and the React application is reading the same information, rather than opening two tails to Materialize, we can open only one tail and then synchronize those events and send the same events to the Node.js application and to the React application. That's going to, you will face a little bit of complexity over there. If you try to do that by yourself, you will need to match the timestamps. It's not going to be hard because Materialize can send you the timestamps every second. So you can match those timestamps to share the same information to the Node.js application and to the React application. And then we have a helper script. So I do not have any 4G antenna or 5G antenna to send events to Postgres or to Kafka and Repanda, but we can build those events and send them to the source. They are going to get processed by Materialize. And another thing is when you are trying to deploy Materialize to production, or you're trying to deploy Materialize to the cloud, you want to build everything automatically inside Materialize. You want to create a source automatically, the same with the Materialize views, with the views, with the syncs, with everything. So I recommend to have a helper script that is going to apply all those changes to Materialize. You can deploy both together. So when Materialize starts, we are going to have a helper script that is going to set up everything inside Materialize, and then it's going to disappear. We can exit, and that's it. So how it looks, how is the data flow? So we generate the events, or we have someone generating the events. Those events are stored in the source. In this case, it's going to be Postgres or Kafka or Repanda. And then we are going to read, process, and serve the results inside Materialize. A microservice is going to read from our backend. Okay, so we have GraphQL, we have the subscription abstraction inside GraphQL. So we can subscribe to Materialize and read through GraphQL the new events in Materialize. So how it is that one event gets here very, very fast. So there's one event, goes to Postgres or goes to Redpanda. Then Materialize is going to read that event. It's going to do an incremental computation and send the incremental result to GraphQL. And then GraphQL is going to share that with the service or with the web application. Okay, it's going to have the same approach. So rather than asking all the time to the backend, to GraphQL, hey, what is the result now? The GraphQL is going to ask to Materialize, hey, give me the results, and everything goes back. That's not the approach with tail. The tail is the other way around. Materialize will send the update to GraphQL, and GraphQL is going to send the update to the web application. So we can do everything in an incremental way. This is going to be almost in real time, or in real time, less than a second. You can see how the event flows from one end to the other end. And we can see here that the application running, okay? So we have the updates here for every antenna. We have a map that is updating all the time, very frequently, or every second there is an update. So we can see, oh, sorry, we can see how every antenna change all the time, okay? So we have a microservice reading through GraphQL the information in Materialize. The microservice, if there is some issue, is going to fix that antenna, is going to deploy a new set of antennas to increase the performance in the area. And then we are going to have our React application reading from Materialize using through GraphQL. We are going to get these results, okay? This is done by using tails and sockets. And it's very cool. I like it. So this question was done by a user in the community. It's a very good topic, is define how to migrate. So we have deployed Materialize. We are running our application. We have Grafana looking at Materialize to see how the memory is working, how much is consuming. We are looking at everything, and we need to change a Materialize view because we want to create a new feature. We need to fix something. So we need to get this Materialize view down, and we need to create a new Materialize view. So we need to define how to migrate. The best approach is to create the new Materialize view that we want to build, or the new table, or the new view. It doesn't matter. It can be also a source. We need to create it. We wait till this new Materialize view consumes all the events, all the necessary information. We can run a tail on top. So when the Materialize view has already consumed everything, we're going to get a result on the tail. So we can test using tails, or you can run a query and wait for the results. Once we have a good result, a result that we are expecting, we can drop the old Materialize view or the old source and all the dependencies. Because, for example, if we have a source and we have a view and a Materialize view, we're going to need to drop everything to replace the source. So remember that you have to do this in every step that you have: create, test, and drop for every object, for the source, for the view, and for the Materialize view. You'll need to do the same. And after you drop that Materialize view, you can rename the new one with the older name. So you are going to have like 100 millisecond downtime over there when you're dropping and renaming. So one way to avoid this is to take a look at the blue-green deployments blog post by Bobby. It's a very good one. He talks about how to do these blue-green deployments with Materialize. So before you are dropping your Materialize view, you can activate the blue-green deployments and point your real-time application or your service to another instance. And after the drop and the renaming has been successful, you can point again to the instance that you are migrating. You can write a script to do this in any language, in any technology. And that's the best way, the best approach to do it using Materialize. So I don't know if anybody has any question. I think here in the question and answer, there's none. Here, okay, so here Andy has been answering some questions. And can Materialize queries tails be writing a doc? How about allowing end user to perform such queries? Okay, so this is a very good question, and I've done this in Materialize in production. So here is the recommendation that I can do for you. If the database that you are building, so you are building your product, you are building an application, and this application can be used by anyone. And when I say anyone, it can be any customer, any user. You will need to do a lot of things to have security on what this user can have access or not. Probably you will need to parse the query to check if they are dropping stuff, if they are creating stuff that you don't want to. And always you will have a little bit of insecurity on that. It doesn't matter if it is Materialized. It doesn't matter which database you select, you are going to have that issue. You need to be really, really, really careful about what you let the user select or not. This is something very dangerous to do. If you are building this for a business, for example, if you're trying to build this for a specific business, you can, for example, create an instance and isolate that instance. So if the user or people from that business run a query that works bad, it only affects their instance because it's isolated. So that's the best case. But letting the user build the query is always is going to be very dangerous thing to do. You can do it, but it's going to be dangerous. It doesn't matter if it is Materialized or any other database. So how do you specify joins and filters? SQL, yes, everything is in SQL. You can write everything in SQL. So you can process the filtering, you can do the aggregations, you can do everything using SQL. So it's very easy to set up a streaming pipeline in real time with SQL. So yeah, everything in SQL. There is no need to learn a new technology like Java, Python, or JavaScript. So I'm going to give another minute. Okay, so that's a good question. I've run thousands of benchmarks to know how many clients can we run in Materialize. So it's going to depend on the memory that you have. It depends on the setup. I've run 3,000 clients at the same time running tails with Materialize, and then the memory got full in. So you can run many clients at the same time. You can use a Postgres pool. So you have a pool of clients waiting waiting to be used. So when you query the pool, there's a client already connected to Materialize, and it's going to be more fast, more in real time. When is the Excel sync coming? Yeah, this is very important if we want to have good integration with all the application. Maybe in the future, you can write that, Daniel, and we can check that. That's going to be very interesting to see. I'm going to wait another minute to see if there is some other question. We are almost getting the whole hour. I was expecting to talk less. Sorry if I've been talking too much. So I'm going to wait a little bit for another answer. And in the meantime, thank you for being here. I hope that the whole meetup has been interesting for you. And if you have any idea, any product, if you are building something, please go to the Joe and Tell and share that with everyone. We're going to be very happy to see that. And if you want more material, you can find that on Notion. And well, that's everything I have to say. Okay, there we have. Thank you, Pablo, for being here.